Today we will design a screw jack using Catia. Screw jack is a device which is used to lift up the vehicle or lift off any heavy objects. The screw jack consists of a tommy bar as well as a body, a spindle, and a hold-up cup along with a washer. All the parts that we are going to design today by using Catia. So we will start with the mechanical design along with the part design, and we will start with one by one. We will have the body, nut, screw, cup, washer, screw, as well as tommy bar. There are 2 screws, a body, a nut, a washer, and a tommy bar. So this is the design drawing. Let me start with the first part, body. So selecting actually it is a symmetric object, so we will draw a profile and then we can revolve it. That means we can use the shaft command. The dimension is given in the diagram. We'll start with the profile. The base is of 20 mm thickness. The height is of 185. First of all, we will draw a profile, then we will use the constraint symbol to change over the dimension. The profile will look like that. Now we are going to give constraint and changing the dimensions. Using the constraint, we can change over the dimension. So from center to the outermost end, the dimension is of dia is of 140, then it will be of 70. Now it is of 3 mm gap we are having, so that line to this vertical line, that is the inner part, it is of 50 mm. The thickness is of 10 mm. Here the dimension is of 20 mm. The base, that is of 3 mm. The thickness is of 10 mm thick material. The dia is of 50, so it is of 25. Half of the dia is of 25, and then for the outermost end it is of 70 mm, so half of the dimension is of 30 along with the center line. Sorry, 70 divided by 2, 35. This dimension is of 10 mm, and from the top it will be of around 40 mm, and then again we are having a dimension of 66 dia. The radius is of 8 mm, and then from the top it will be of 66 mm dia, as well as the height is of 40 mm that we have to draw. A dimension is of next over constraint, it should be avoided. From the outer end, it is of 40 mm length. Then we will have a line we will use poly profile to connect that line. Actually, there is a groove over there that we have to show. You can see that at a distance of 40 mm from the top, there is a groove that we are making. The distance of 10 mm. Is of 40 mm. So the total height is of 185 mm. After the center distance of 50 mm, that is total die of 100 mm divided by 250 mm that we had missed. So only the profile is not created. So now the profile is made. From the center it is of 33. Actually there is a die of 66 now. So that we are making. The groove has to be fitted correctly. So using the chamfer symbol, we make that groove-like structure. And again for inner side, it is of 3 mm. Over here it is of 8 mm radius. The extra is there that we have to delete until unless we can't able to revolve it. So if you use the shaft command, we can able to, as it is symmetric object, we can able to revolve it. So this is the body of screw jack. That is the first part. We will start with the second part. Start with the second part. Nut. It's just like what we had made the nut on the first class. So again using the profile, we are making a shape of nut without dimension. Then using constraint, we can change over the dimension. Now we will give the dimension. So from the center, the dimension is of 90, then of 50, two dimensions are there. So one die is of 50, another die is of 90. So from the center it is of 19, and then the outer is of 45. From the bottom it is of 45. This is of 10. And there will be a circular disc-like shape with a radius of 5 that we have to make. Radius of 5 mm. There also the radius is of 5 mm on either side. We will add that, revolve that, and this is how the nut will look like. The second part is made ready. Now we go for the third part. It is the screw which has been inserted inside the body. So we'll make it. The dimension is given. It is made of a square thread of dia 38 into 7. We'll start with profile. The dimension is of a simple profile will make, then using the constraint we can change over the dimension. Actually, the total height is of 240. Half of dia 22 is 11. And then from the top it is of 83. Total height is of 270. Yes, it's 240. We'll make it a symmetry to the axis. And from the top it is of 83. Then From here, that dimension is of 12. We will have chamfer command with an angle of 45 degree. The corners are made chamfered, and we will revolve this part using shaft command. And in this, we are going to insert a hole also. Now we have to insert a hole over there. So selecting the sketch command and using the pocket command with a hole definition. The hole is of dia 22, threaded hole of metric thin pitch of M8 type. Threaded depth is of 30. Hole depth is of 35. By using this hole definition, we can make different types of holes as per the given, which is given in the question. And again, we have to make a hole on the body of this threaded shaft so that the Tommy bar will be inserted over there. So it is of 35 mm from the bottom, and using the pocket definition, we are making a hole up to the other side. So the third part is made. We'll make the fourth part. That is the cup. So the compass is going to be fit on the top of the screw jack. The dimension is of 22, 40 feet. Two diameter are there. The center diameter of 38. Total height is of 42. The thickness is of 6. And we are having a cut over a radius of 6. We'll use profile command. This is also a symmetric object, so that we'll use profile command and changing the dimension by using the constraint command. Then we can use the shaft command to revolve it. From the center, the outer is of, from inner side it is of dia 22, that means 11. Outer side it is of 45 divided by 22.5. This thickness is of 6 mm. Total height it is of 42 height. The thickness of 12 mm at bottom. 42, then that is of 12. That is of 12. And it is of 45. It is made as over constraint. That should be avoided. If not so, we can't revolve it. There is of 6 mm. Now using the shaft command, we had revolved it, and now you have to make a hole at the top, which is of dia radius 5. Of radius 5. And now using the pocket definition, we can have a pocket of radius 5. Now we will use the mirroring command or else array command, circular pattern, with the circular pattern, so that we will have 4 slot of radius 5. Now we will draw a washer. The part is the washer. It's given as dia 35. Then angle is given. There are two dia 25 and dia 35 with an angle of 90 degree. Then thickness is of 8, and then another one the dia is given as 14.5. So we'll design the washer. The thickness is of 8, and then we are having two diameter of dia 25 and dia 35. We will use two circles. Dia 35. Using pad definition, we made a dia of 35 disc. We will make a hole by using the hole definition command. Depth is of 8. Angle is of 90. The dia of the hole is 14.5. Depth is of 8 mm. And now we will draw other two parts. And then we will assemble it. Let me to share my screen once again. So now we will draw the next part, that is the screw. So the screw is of M12 type, the thickness of 6 of 90 degree. Then we are having a slot of 3 mm. The total height is of 30. We'll draw that screw. So using the profile, we will draw a profile of screw. Then we will give the dimensions. From the center, so using constraint, we can, the total length is of 30 and it is of M12. Make it a symmetry. Total 30. So 3 mm. Total 12. The angle is of 45. So using shaft command, we will revolve the screw. We have to reconstruct it. We will make a slot after completing the profile. Now we will make a slot of diode, that is of 2 mm gap. Total is of 24. So through along the length that we have to make a slot. That means through along the surface. Can use line command to make two lines, which is parallel lines with a dimension of 2 mm. That means the distance between the two lines is of 2 mm. The axis line, the central line that we are making, to make it as coincidence with the central line. We'll make these lines to coincide with each other. That is symmetry. Now the profile is made, and we'll remove the center hidden line. Then we will remove the material using the packet definition for 3 mm. Now the screw is being made. Next part is being made, and we have to make 60 screw and Tommy bar that we have to make. Next part. Next part is the Tommy bar. Tommy bar. This is the last part. Then we will assemble it down. So the total length of the Tommy bar is 275, and then we'll have a dia 12 mm rod. We will make half of the profile, and we will revolve it down using the shaft command. Total length. We are making a symmetry. That is of dia 12. That means of dia 6 on another side. This length is of 62. It is of 6 mm. Total length is of 275 mm. So there we are having a chamfer the length of 5 mm and the angle is of 45. The angle is of 45. There is a chamfer at this end and a circle, semicircle at the last end that we have to make. Angle is of 45 and 4 mm chamfer, and the dia is of 20. Then a semicircle of 10 has to be made over there at the other end. As the half part only been made, we are connecting it with a semicircle only. So during shaft, using the shaft command, once it has been revolved, then the total dia of 20 will be made. Now the radius is making as 10. So now we will revolve it by using the shaft command. Now the Tommy bar is made. It is of 45 degree. Now the part is being made and the Tommy bar is also been saved. Now we will go for assembly design. So we will import one by one part. So we'll have, this is the assembled view, how it should be look like. So we'll import the product one by one. The name is given as screw jack, the completed part, and we will import the part one by one. First, we'll open the body. The second part, is the cup. There is the nut which has been fitted. By using the manipulation command, we can able to move any part with respect to its axis. So the part is going to be fitted, and then the third part is the screw, and again using manipulation command, we can drag a part as well as make them to fit by using moving it along axis. Only a half of the thread is being inserted. So out of 275 mm, we had made only 100 mm to be made inserted. Now we are inserting the Tommy bar. Using the manipulation, we can take over the Tommy bar and we can insert it. Now the Tommy bar is being inserted inside the hole. The Tommy bar is now being inserted. Then the next part is the cup. To be inserted. Then the screw, washer and then screw. Now we have to insert the washer, then the screw. Using manipulation command again, we can take over the washer. Again using the manipulation command, we will take over the washer on the top side. Now the washer has been fitted. Now we have to fit the screw. The screw is being imported now. By using the manipulation command, we will take over the screw to the top. The center line of the hole and the screw should be matched. Now, using the constraint, we can able to make this part to be fitted with the hole. Now the part is being fitted. This is the assembled view of screw jack. We will hide all the different parts planes, and the assembled screw jack look like this, and we will save this part as screw jack. So this is the way of drafting, designing, and assembly of screw jack. Thank you.